Good afternoon, Tigers. Today we're going to be talking about slope and y-intercept. I can find the slope and y-intercept of a line given a sequence, graph, verbal description, or table. So as you can see, we're going to be finding the slope and the y-intercept from a variety of ways that the information will be presented to us. Sometimes we find the slope given a formula. So if we're given the formula, that means you're just going to be given a set of two ordered pair. So you're going to given the set of two ordered pair, and then you use the formula y sub 2 minus y1 all over x sub 2 minus x sub 1, meaning the change in the y's over the change in the x's, or otherwise known as the rise over run. We'll be using that in just a little bit. That's one way to do it, again, if we're just given two ordered pairs. Sometimes we're going to see a graph. And so when I see the graph, I could do the formula we just talked about, which is to just choose the 2 points and calculate the slope. But it's a little bit easier if I just count. So that's what we're going to be concentrating on today. So in this first example, we see a line. I see a line that happens to be a positive line. In other words, it's going up. So that is a positive slope, and we're going to count from this point to this point. That's where we're trying to get from. So in order to get there, the first thing we're going to do is count how many places did I go up. So I went up 1, 2, 3, 4, 5, and then I went over a total of 1, 2, 3, 4, 5, 6. So the slope then is 5 over 6, and the 6, I guess, got moved here. Whoopsie. Let's write that as the change in the rise, or we went up 5 and we went right 6. Now you can see the way that I wrote it with a positive, but our final answer would just be 5 over 6. We know that we were going up to get there. So you mean when the slope is positive or I'm going up, then I count up and over? That is exactly right. You're going to go up 5 and over 6 in that situation. Now the y-intercept simply means the place that the graph crosses the y-axis. So I can see that the y-axis is crossed at about this point. It's actually halfway between. It's hard for me to get my pin in between there, but it's halfway in between 1 and 2. So I would say that the y-intercept is 1.5. Generally speaking, you guys, we're going to give you y-intercepts that are actually right across a point. But in this case, it's a little bit, you can see it's a little bit off from that. But it does go right in between the 1 and the 2. So that would be 1.5. So the y-intercept simply means the place that the graph crosses the y-axis. On the second example, once again, I notice that I have a line that is going up. So right away, I know that that means that it's a positive slope. And I want to count from the point that is highlighted here or pointed out to the point that is at the top. So when it's a positive slope, you're going to start down and you're going to count up. So we're going to count up 1, 2. Let me mark that. We're going to count up 1 and then 2. And that means that my rise was a 2. That's a positive 2. And then I'm going to count from this point over to this point. So that would be a total of 1, 2, 3, 4, 5. And that's also a positive 5. So we already knew that up front it was going to be a positive. So the slope then I would say is 2 over 5, or 2/5. And that pattern should just continue. So it would go up to over 5, so on and so forth. Or we could also go down to, so if I go back to this spot, I could go down to 2 and then back 1, 2, 3, 4, 5. Sorry, my pen is just not cooperating. Because if I went down 2 and left 5, we also know that a negative over a negative would make a positive. So that would just be if, let's say that my line was kind of running off the graph and or I needed another point, then maybe I might have to kind of be creative with my points. So that just know that you can go either way. You can go down and left or up and right. Both of those are actually positive. As far as the y-intercept, this is really not a great example because it's going to be a little bit above 1 and not quite a half even, I would call that y-intercept a positive 1 1/3. That would be my answer because it's just a little bit above the 1. Once again, most of the time your y-intercept, it's going to be very obvious. It's going to be right in between, right on that intercept line. But as you can see, it's just a little bit above the 1. On our last example, I want you to go ahead and pause the video and see if you can do that on your own. I notice this time it is going down, but you're just going to be counting the same. So if you feel comfortable enough, just go ahead and pause the video, and I want you to do that on your own. If I'm counting and I'm going down the mountain, then I'm going to start at the top and then I'm going to count my way down. So we do the rise first, and rise is like in an elevator. So rise just means going up and down, and then we run from left to right. So that's what I always think about. So we elevator, and then we would run. So we would go down then. We would actually just go down one position. So that would be a -1. And then that's going to be 1, 2, 3, 4, 5, 6 to get to that point, or a -1/6. So just like I was talking about before, I can go down 1 and over 6, or I could go up 1 and back 6. 1, 2, 3, 4, 5, 6, and that point should hit there. If I had a ruler and that was a straight line. So one thing you need to remember, you're going to get into this quite a bit in this unit, is that that negative can either stay with the numerator or the denominator, but it cannot go with both, because as you guys know, a negative over a negative would make a positive. So I can either go down 1 and right 6, or I can go positive 1 and left 6. And again, that negative just travels with either. As far as the y-intercept, it's going to be, looks like halfway between 1 and 2, so that would give me 1 1/2. As far as a slope is concerned, it is perfectly acceptable for you to leave it as an improper fraction, because it's a lot easier to graph if I just have a numerator and just have a denominator. But as far as the y-intercept, it's going to be easier for you to graph if you break that into a mixed number. Just a thought. So slope, leave as improper. Y-intercept, if you were to have to graph it, you're going to want to change it into a mixed number. All right, so now here is the actual formula given ordered pair. So we know that the formula, once again, is our change in our y's over our change in our x's. So I'm given 2 points. I'm given point A, I'm given point B. So if I were to plot these, I could find them the same way that we just did, where we could count. If I actually had those 2 points, we would connect it with a line. But if I don't have a graph handy, if I don't have that, then I can just use the formula. So as you can see, we see x sub 1 and y sub 1. That simply means the first x coordinate and the first y coordinate in the first ordered pair. And then just to distinguish, we have x2 and y2, or x sub 2 and y sub 2, meaning the second x and the second y. That's all that means. The top is going to be the change in the y's. The bottom is going to be the change in the x's. So then I would say 7 minus 1, and I love arrows. I would really encourage you guys to use arrows to just kind of make sure that you've included the right numbers in your formula. So I have 7 minus 1 on the top, and then I have 5 minus a -2. Notice that is a -2 on the bottom. And then, of course, that simplifies as 7 minus 1 is 6, and then 5 plus 2 on the bottom, or 7. So the slope of this particular figure then would be 6 out of 7. Go ahead and try the next two. Go ahead and pause the video. I want you to try the next two on your own, see what you come up with, and then I will go over those with you. So go ahead and pause it, and then continue when you are finished with the next two. For this example, we have on the top, once again, I said I love arrows, so I would label this x1, y1, x2, y2. On the top, I have 7 minus 5. On the bottom, I have 4 minus 2. That simplifies down. 2 out of 2 is really better known as 1. And so our slope, it doesn't matter if I'm plotting a point and going up 2 and over 2. it'd be exactly the same thing. I'd end up on the same place on the line if I was going up 1 over 1. And I wouldn't be on the same place on line, but I would be in the same line, or that would make a linear function. So it's exactly the same if I go up 2 over 2 or up 1 over 1. It would be the same line. For the second example, we end up with negative 3 halves. Well, where did that come from? Well, we've got x1, y1, we have x2, y2, negative 2 minus 4 on the top, 3 minus negative 1 on the bottom. I love that there's parentheses here. That separates, kind of organizes our work, because we know that we are still subtracting. It doesn't change because it's negative. The rule is to subtract y's on the top, x's on the bottom. So be sure to include the negative. So we end up with negative 6 over 4, much better known as negative 3 halves.